Before I do that, I'm just going to draw attention to the nervous system, the autonomic nervous system. I've disabled that currently. And that's because as I make big changes to the blood pressure or other parameters, the model sees that and, like the human would, responds to those things. So if I want to focus on one system and what it's doing, I need to take out the autonomic nervous system so that it isn't controlling things while I'm trying to control things. And what I'm going to do here is something that's very simple. I'm just going to focus your attention on the blood pressure waveform and on this value, the pulse pressure, that's right now at about 50 millimeters of mercury. And the model that you should have in your mind for what determines the pulse pressure is the heart ejects a volume into the aorta. The aorta has to expand to accept the volume that the heart pumps into it. And if the aorta can easily expand, when the heart pumps into it, the aorta expands and the pressure rises only a little. If instead I make the aorta like a steel pipe and now push the heart's volume into it, think of what that's going to do to the pressure in the aorta. And now I'm just going to stiffen that aorta. I'm going to reduce its compliance by a lot. So the pulse pressure is very close to 50, and I'm going to reduce the compliance of the aorta. That means I'm going to stiffen it, more like a steel pipe. And as I do that, you'll notice that now, just qualitatively, visually, you can see that this pressure is spiking higher and changing more. If we now look down in the data display, you can see how much. It was about 50 was the pulse pressure before. It's now 65 millimeters of mercury. So what does that mean? That means that now when the heart ejects into this stiffer aorta, the pressure naturally rises more.
So you can basically undo anything you did in your intervention through that mechanism?
I can always reset and start over. I can also save states, as many as I want, all along. At any point I can save a state, and then I can go right back to that saved state. In fact, that's what I did to prepare the session. I saved several states so that I can use them to teach you all.
Mm-hmm. So before you go into a classroom, you always set several saved sessions or however you do it to prepare for that class?
I create the models and the displays to teach what I want to teach.
And how long does that typically take for you to do this?
I can set up some simple things in 5 minutes' time. It depends on the complexity of what I want to display. It also, I'm a very compulsive person. I'll go through to make sure that it's right, so I'll usually go through it several times to get the numbers just right. But that's just a question of how, the detail that you want to display. So you asked about preparing for a class. Suppose that I prepared for a class and then I had an exercise that I wanted you to be able to take home. I can take this material that I've created, just like this here. I can go to create a new exercise. I can give it a name like today, and then I can add viewers to it. And suppose that I want to add all of these 3 viewers that I have on the screen. So there's 1, I'll add the other 2, and then I might want to say try dobutamine, and then create the exercise. And then I can go to custom exercises, and there's the one called Today that I created, and I could send you that file, and you could pull up that file, and it would say Today, and here it would display the femoral artery pressure, the data panels that I showed you, and then my message to you, or whatever I wanted to put in it. Try dobutamine. And then you would say, okay, why does he want me to try dobutamine? Well, maybe if I go over here to the drug and fluid infuser and I find dobutamine. So I'm going to go into the pharmacy I'm going to go into drug categories, and one of those categories is vasoactive drugs. Within those vasoactive drugs is dobutamine. So I'm going to add that drug. Then I'm going to put a dose in that makes sense, what I would actually use in the intensive care unit, for example, 10 micrograms per kilogram per minute, and then I'm going to start infusing it. And what you're going to see happening here is what dobutamine does, which is, it's subtle at first, but it's raising the pressure. You see that? The blood pressure is going up, the pulse pressure is going to go up too. And you can ask yourself not just what's going to happen to the femoral artery pressure, well, that's what I've put into the exercise, but if I give you the whole program, you can go and ask, well, what's going to happen to heart volumes, what's going to happen to other pressures, what's going to happen to urine output. So now in the waveform display is the blood pressure again, this time the aortic pressure, that's the black line here. And underneath it is the pressure in the left ventricle. That's the left ventricular pressure, also as a function of time. And you'll notice that there's a period of time when those two pressures are the same. Now, talking about why those are the same is a very valuable lesson, because it's at only one point in the pumping cycle of the heart when those two pressures are the same. And that's when the valve in between the left ventricle and the aorta is open. In symbiosis, I can make it an abnormal valve too, and I'll show you how that changes things. You'll notice that the pressures are the same over the hump and come down together, and then they diverge again, right at that point where my pointer is. And of course, it's at that point that that aortic valve closes again and allows the pressures to separate. In my data display, I've shown something called aortic valve resistance, and it's set to a very tiny value because the normal aortic valve doesn't present any substantial resistance to ejection. I'm going to change that in just a moment, but before I do, I'm going to show you again this left ventricular end diastolic volume. How full is the heart at the end of the time that it fills? Because if I make the aortic valve get tighter and tighter and tighter, you can probably imagine that the heart is not going to be able to empty as fully.